Hello friends, I am Hitesh, and in this session I am going to solve for you about 41 problems taken from CAT 16, 17, 18 and 19. If you stick till the end of this video, you can easily improve your scores in quant by 12 to 15 marks. How? Every year there are 4 to 5 questions from geometry in quant section of CAT. While solving these problems, I'll be trying to cover basics of that problem, some theory behind that problem, and if possible, I'll be covering the trick methods as well, or the shortcuts. But before you go any further with this video, I'll suggest you pause this video, go to the description section of this video. There, you'll find a PDF. Try and solve questions from the PDF. If you feel you're stuck, if you feel you need to verify your methods, if you need to verify your answers, come back to the video and I'll try and post an answer sheet as well for this particular session. So let us get started. First problem that I have on the screen is from CAT 2016. Hypotenuse of a right angle triangle is 26. What could be its perimeter? Only one side has been given of a right angle triangle and we are asked to find the perimeter. Perimeter means sum of all sides. This question involves knowing or remembering Pythagorean triplets. 26 is basically 2 into 13. With 2, I cannot form a Pythagorean triplet. With 13, I can form a triplet of 12 and 5. 5, 12, 13. That means the other two sides will also be double in length. So if I add all this up, I will have the perimeter as 60 units. That is the answer option D. So this question hinges on your ability to be able to recall Pythagorean triplets. For a benefit, I'll cover 4 to 5 triplets that are very common in CAT. The simplest one to remember is 3, 4, 5, most commonly used triplet. Then we have 5, 12, 13, the one that I use right now. Then we have 7, 24, 25, 8, 15, 17, 9, 40, 41. And if you want to go extra mile, 20, 21, 29. Try and remember these triplets. You will keep coming across these value appear aptitude tests. Let us try the next problem. ABCD is a rectangle and E is a point on AD such that CE is equal to CB. The ratio of area ABCD to that of triangle EDC is 6 by root over 5. Find the ratio of AD upon DC. First thing that you guys need to do is represent this in a simplest possible manner. See, this is the rectangle that I have got. Names A, B, C, D. Now, E is a point on AD such that CE and CB are equal. So I'm drawing a line here. I'm calling this point E and I'm joining E with B further. Now I have been told that CE and CB are equal and I have been given an area ratio. If I assume this to be X, this is going to be X, this to be Y, this to be Y, this is going to be X. So ABCD area is basically X into Y divided by, I want EDC area. For EDC, if I take Y as the height, DC as the height, I need ED as the base. Now look at this triangle. This is Y, this is X. So ED, value of ED, I'm getting as root over x square minus y square. Basically, ED is the perpendicular, DC is the base, and EC, x is the hypotenuse here. So area of the triangle is half base into height, and that is given to me as 6 upon root over 5. So here I am able to cancel y. This 2 will go upwards and that will cancel with this 3 times. So basically I end up with x upon root over x square minus y square. Now please pay attention here. I have got 3 upon 5, root over 5. You don't have to cross multiply, don't have to perform squares. X represents 3. So x square should represent 9. So what should I subtract from 9 to make it 5? I should subtract 4. So y square is 4. That gives me x is equal to 3 and y is equal to 2 in the ratio. The question was find AD upon DC. So AD is x and DC is y. X upon y is 3 by 2. That is answer option A. Again, think of this. Ratios of areas are given and ratios of sides are required. A lot of people will end up applying similarity here. This is not a similarity based question, guys. Let us move forward. In the triangle ABC, angle A is 40 degrees. Angle O is the in center of the triangle. Find angle BOC. So here I need to know the property of in center and how do we find in center. I'll give you the formula for this. If you are aware of this formula, the angle at the in center is 90 degrees plus half of the opposite angle. So here it is 90 plus half of 40, that is 110. That is the answer option B. Now what is the origin of this formula? Once you understand that, you don't have to mug up this formula. You can simply recall this formula very efficiently. See, if I say that this line BD is the angle bisector of B, and if I say this line CE is the angle bisector of angle C, and this is the in center point. In center is achieved at by drawing angle bisectors. Here it has been called O, but usually it is called I. Now, if I say this angle and this angle are B and B, this angle C and this angle C, what I have is A plus 2B plus 2C is equal to 180. A has been given to me as 40, so I can find B plus C as 70. Now angle O plus angle B plus angle C form 180. So this comes out to be 70. B plus C comes out to be 70. So O comes out to be 110. See, I'm able to find 110 by this method as well. So I'll suggest you, if you can remember, this is the approach. If you cannot remember the result, go through these steps. Again, when you are going to bisect something, don't assume it as by 2 by 2. You're wasting time. Assume simply 2b here and 2c here. In that way, you can work with integer values b and b and c and c. I hope this helps. Let us move on to the next problem. A pyramid has a square base and its vertical height is twice the side of the square base. This is critical. Find ratio of area of any of its triangular face to that of the square base. This is a question based on three-dimensional geometry, 3D, based on basically pyramids. What we have here is a square base. Let me draw this base one more time. It is going to be useful here. See, in the center, imagine there's a pole. That is the vertical height of the pyramid. This side is x and this side is 2x. So if I look at this horizontal distance, this will be x by 2. And if I look at this slant line, that is the hypotenuse here, that will be 2x square plus x by 2 square in the root over. Now, why am I trying to find this? Imagine that this is one of the sides of the pyramid. The base of the triangular side is x. The height, if I could find out, I can have the area of the triangular side very easily. So this line that I just now found out, I'll highlight it for a different color. See, this height that I just found out is nothing but the height of the triangular surface. So that turns out to be, see, x common. I will have 2 square plus 1 upon 4 square. So I will have root over 17 by 2 into x as the height. Height multiplied by base multiplied by half is the area of the triangular surface divided by area of the square base. That was the question. X square cancelled. You have root over 17 by 4. Answer option D. This question is more relying on your ability to visualize. So if you solve a couple of problems like this, you should not face any problem. See, there were very little calculations involved. I simply put the pole in the center, I found out the base, I was given the height, and then from there I simply squared. That is the only calculation involved here. I hope this helps. Let us go to the next problem. In a trapezium ABCD, AB is equal to 10, CD is equal to 6, A plus B is equal to 90 degrees, and A is equal to B. Find height of the trapezium. Let me plot this for you first. In trapezium, two sides are parallel to each other and two sides are non-parallel. In this case, we have been given a crucial hint that the angle A and the angle B are equal. Now, what does it mean in terms of a trapezium? If I say angle A and angle B are equal, that means angle C and angle D are equal. That means it is a isosceles trapezium. And very beautifully, the value is given to us as A plus B 90 and they are equal. That means A and B both are 45. This is given to us as 6. This is given to us as 10. So if I draw perpendiculars, in an isosceles trapezium, this part and this part will be equally divided. So that will be 2 and 2. And because this is 45, this is 90, this angle has to be 45. It's a isosceles right angle triangle. So if this is 2, this one has to be 2, and that is the height. Again, no calculations involved, simply understanding the property of isosceles right angle triangles and isosceles trapeziums. Let us carry on with this. ABCD is a trapezium in which AB is parallel to CD. M and N are midpoints of diagonals AC and BD respectively. If the ratio of length of sides AB ratio CD is 3:1, find the ratio of length of MN to AB. Now, AB is the longer length, CD is the shorter length. The ratio is 3:1. Again, you have to draw these diagrams neatly. As you can see, there are no diagrams available in any question so far. You cannot apply folding methods, approximations, random akkad bakkad bambe bo. Look at the question. There's no option, or there are no options here. So it's a theta based question. Type in the answer based questions. I'll have to plot the diagonals as well. Let me change the color here. All done. A, B, C, D. This is 3 in the ratio. This is 1 in the ratio. Let us call this point O. Now, if you know something about similarity of triangles, this angle here is equal to this because of the lines are parallel, and this angle here is similar to this, equal to this. Similarity of triangle has been proven. So this 1:3 will appear on sides as well. This side, if it is 1 in the ratio, this side will be 3 in the ratio, because the upper triangle DOC and the lower triangle AOB are similar. Now M is the midpoint and N is the midpoint. If these are the midpoints, that means these distances are 2. From C up to M, the length is 2. From C up to O, the length is 1. So from O up to M, the length is 1. From O up to N, by similarity, by symmetry of the structure, it will be length 1. Now observe, triangle A or triangle OMN and the triangle OAB are again similar. So whatever are their side ratios are going to be their base ratios as well. Here OM, here I am getting OM as 1 in the ratio. I am getting OA as 3 in the ratio. So if you ask me what is ratio of MN upon AB, base upon base, I'll say 1/3. We cover this property sometimes in similarity of triangles, sometimes in parallel lines, sometimes this is also called basic proportionality theorem. It is also related to midpoint theorem. So if you do not know these properties, flip some pages of your book, you will find these properties there. Or you can visit one of the lectures available in the playlist based upon lines and triangles. A closed rectangular box has surface area of 399 square centimeters. The sum of all the edges of the box is 128 centimeters. The box is inscribed inside a sphere. The diameter of the sphere is. Here I am getting hints about a rectangular box. So if you ask me for surface areas, if I assume the sides to be A, B and C, surface areas look like 2AB plus BC plus CA. And if you ask me about edges, so length A is available 4 times, B is available 4 times, C is available 4 times. Here it says sum of all the edges. So I will have 4 times of A plus B plus C as 128, and this is given to me as 399. Now, very beautifully the question has been framed for a sphere. When you put a rectangular box inside a sphere and you imagine this through a cross section, you're looking at a rectangle fitted to a circle. So the diagonal of the rectangle is basically diameter of the circle, in this case diameter of the sphere. So I remember the formula for diagonal of a rectangular box would be a square plus b square plus c square inside the root over. Here I can apply the property of a plus b plus c whole square as a square plus b square plus c square plus 2ab, 2bc, 2ca. Now this I can find out as 32 ka square, that is 1024. This is given to me as 399. So 400 subtract kar do yahan se, that is 624, 1 less 625. So here you have square root of 625, that is 25. 25 centimeters is the diameter of the sphere. This is the answer we're looking for. Again, this was more based on algebra than on geometry. What do we have here? A triangle ABC is isosceles. AB is equal to AC and angle A is equal to 120 degrees. The area of triangle ABC is 75 root 3. What is the length of side BC? Here I am able to see a pattern in these values. See, you have to draw diagram big enough so you can put values in those. See, vertices I am taking as A, B and C. this angle is given to me as 120 and these sides AB and AC are given equal to me. That makes these angles 30 and 30. Here, I usually cover this property while talking about right angle triangles and equilateral triangles. The side ratio for 30, 30, 120 guys is 1:1 root over 3. So if this side is x, this side is x, this side has to be root 3 times of x. Now, in an isosceles triangle, if you drop a perpendicular between the equal sides, that perpendicular will also bisect the angle and the base equally. So this part is half of root 3 by x. Now I can perform squares and subtract, or I can apply another property or another ratio called as 30-60-90 ratio. That is 1 ratio root 3 ratio 2. See, opposite to 90, I want there to be a length of x. So opposite to 60, it will be root 3 by 2x, and opposite to 30, it will be x by 2. So x by 2 is opposite to 30. Opposite to 30 is my height, that is x by 2 in this case. So I have got the height, I have got the base of the triangle, so I can find the area. Area is given by half of base multiplied by height. That is given to me as 75 square root 3. So here root over 3 cancelled. What I have is x square is equal to 300, or x is equal to 10 root over 3. Now please do not make the silly mistake. The question was not about finding x, the question was about finding root 3x. Why? The length BC is required. So root 3 multiplied by x will be 30. 30 units is the answer, guys. Again, this was a data based question. Here, with the end of fourth problem, we have completed CAT 2016 questions. Let us try some questions from 2017 and onwards. From a triangle with sides of length 40 feet, 25 feet, 35 feet, a triangular portion GBC is cut off where G is centroid of ABC. The area in square feet of the remaining portion of the triangle ABC is. Now, we have been given a triangle. We have been told that some area has to be cut off from this particular triangle. And the area is being cut off from the point we call centroid, G. So first let me plot this diagram roughly. Yeah. So if the vertices are A, B, C and the points are D, E, F and this point is G. We want to know when this area, I am plotting with green color here, is cut off, how much area remains. Now the property of centroid and medians is that if you draw all three medians, you get 6 equal areas. These areas I am putting dots in, they are all equal. So from the triangle, if I cut off 2 portions and if I leave these 4, so the remaining portion is 4/6 of what? Of the entire triangle. So that is 2/3. 2/3 of the area of the entire triangle. Now what is area of the triangle? The area of the triangle is S, S minus A, S minus B, S minus C. What is the semi-perimeter? It's 40 plus 25 plus 35 divided by 2. This is 60 and 40, 100, that is 50. That is 50, 50 minus 40, 10, 50 minus 25, 25, 50 minus 35, 15. Why do you want to write formulas first and then put values? If you know the formula for sure, start putting values there. So from here I can take 10 common. So this becomes 2 by 3 into 10. From here I can take 5 out. So what I have is 5 here and 15 here. That is 75. 75 I can take one more 5 common. Remaining is root 3. This root 3 I can cancel. So denominator becomes the root 3. So what I have is 20 into 25. That is 500 divided by root over 3. That seems like answer option B. Again, look at the steps involved. We simply thoroughly solved the problem in 4-5 steps. Do not apply random tricks. Do not apply methods you're not sure of. You'll end up with wrong answers. A lot of people at this stage, they start appearing mocks and they start applying random methods like folding the paper, cutting the paper, Chudi Kangan method for circles. Don't do this, guys. You can thoroughly solve these problems. These are very basic problems. If we come across a complicated problem, we'll try some shortcuts, we'll try some tricks. 10th problem. Let ABC be a right angled isosceles triangle with hypotenuse BC. BQC be a semicircle away from A with the diameter BC. Let me first plot this up. Let me first put this on paper. We have a right angle triangle. And because the hypotenuse is BC, so obviously A is the point where it is right angled. Now we have an arc away from A and with BC as the diameter. So imagine this is the arc that is away and the name for the arc is BQC. Now going forward, let BPC be an arc with a circle centered at A, lying between BC and BQC. The length of AB is 6. Because the triangle is isosceles, this is going to be 6 root 2. Now, with A as the center and B as the end point of the circle, another arc is drawn, and that arc is between the previous arc and the hypotenuse. This arc has been called P. The question is, can you find this enclosed area? So I can think of very simple steps here. See, I'll find out quarter circle with center A. From that quarter circle, I'll remove the area of the triangle. So I got this area. And from the semicircle, I can remove this area, the one I'm putting ticks in, and I'll have my answer. So quarter circle is 1 by 4 pi r square. That is 6 square, 36 upon 4. So 9 pi. This is the area from A to B to P to C entirely. Then area of the triangle is half base into height. That is basically 18. Now, if I want the area of BPC arc with BC as the line opposing it, fixing it, I have got 9 pi minus 18. Now, area of BQC is basically a half circle with pi r square. What is r here? 6 root 2 by 2. Because see, for an isosceles right angle triangle, the ratio is 1 ratio 1 ratio root 2. So here I get this as 3. So if I square this, I will have 3 square 9, 9 pi, 2 and 2 cancel. This is 9 pi. So my answer will turn out to be 9 pi minus 9 pi minus 9 pi minus 18. This is the area of the portion BPC. This is the area of BQC. Subtracting both, I will have my answer. That is 18. There is no pi involved. 9 pi is getting cancelled, guys. So answer option is B. Now this is the current level of CAD you can expect. You are supposed to calculate 2-3 steps and you are supposed to apply 1 or 2 concepts combined. Next one. At any point, if you feel overwhelmed with all of this, simply pause, listen to a couple of songs, and then come back. A solid metallic cube is melted to form 5 solid cubes whose volumes are in ratio. Guys, volumes are in the ratio 1 ratio 1 ratio 8 ratio 27 ratio 27. The percentage by which the sum of surface areas of 5 cubes exceeds the surface area of the original cube is nearest to. So again, I'm working with proportionalities. Nobody says you have to find every length, every value. I know one thing, volumes of cubes are proportional to side cube and surface areas are proportional to side square. And when you melt things into other structures, you have to conserve or make the volume same. Right now, the volume ratios given to me are 1, ratio 1, ratio 8, ratio 27, ratio 27. So I see the total volume to be 54 plus 8 plus 2 plus 2, that is 64. Now this is cube of 1. See, what is this? This is proportional to side ka cube. I want to find side first. This is cube of 4. This is cube of 3, cube of 3, cube of 2, cube of 1 and cube of 1. Why did I do this? This was parameter for volume. I have got side ka parameter now. Now I can go for surface areas. They are proportional to side ka square. So side ka square 16, 9, 9, 4, 1 and 1. So this is proportionality of areas, which is 9 plus 9, 18 plus 4, 22 plus 2, 24. Surface area of the 5 combined is 24. Surface area of the original one is 16. The question was, the surface area of the 5 cubes combined exceeds the original one by how much? It exceeds the original one by 8 by 16 into 100 seems to be 50% increment. That was the problem here. That was the question here. Now understand, this question is more about proportionalities and ratios and less about geometry. That is why we keep on saying if your arithmetic is good, if your numbers are good, other topics will seem easier. Now what does this question say? A ball of diameter 4 centimeters is kept on top of a hollow cylinder standing vertically. Alright. Height of the cylinder is 3 centimeters. While its volume is 9 pi centimeters. Then the vertical distance in centimeters of the topmost point of the ball from the base of the cylinder is. Alright. So here we have a ball, a spherical ball that has been placed on top of a sphere, on top of a cylinder. Imagine this rough thing is a cylinder. Now this cylinder has a height of 3. This ball has a diameter of 4. And volume of this is 9 pi. Cylinder volume is 9 pi. Now if you imagine, or if you look at this closely, if I perform a cross section cut here, I'll see a circle. That is my ball. And here, this cylinder, this length will appear as a chord. Let me draw this in a slightly better manner. Let us say this circle is the cross section of the sphere or the ball, and this straight line is the diameter of the cylinder. This is basically going to become a chord of the circle. Now please pay attention. The formula for volume is pi r square into h, which is given to me as 9 pi. So if I cancel this out, I've basically got radius of the cylinder as root over 3. So this length from here to here is root over 3. This radius is 2. Now recall what is 30, 60, 90 ratio. It is 1 ratio root 3 ratio 2. 2 is the hypotenuse and root over 3 is opposite to 60 degrees. So if I draw a line here, this angle is 60, this angle is 90, this angle will be 30. So this length will be 1. Now here the height of cylinder is already 3. Already height is 3. From there it is above. The center of the ball is above by 1 unit. And further above there is a length of 2 units. That is the radius. So how away or how far is the topmost point of the ball from bottom of cylinder? 3 units plus 1 units plus 2. So the combined height of all of these is 6 units or 6 centimeters. Again, what comes to my rescue? The 30, 60, 90 ratio. So far, This is the 12th problem we are solving, and I've already used it thrice. So guys, 30, 60, 90, 45, 45, 90, and 30, 30, 120 are very common ratios. You'll keep coming across these ratios while you appear aptitude tests. Let us run the problem. Let ABC be a right-angled triangle with BC as hypotenuse. Lengths of AB and AC are 15 kilometers, 20 kilometers, respectively. The minimum possible time in minutes, minimum word is critical here, minimum possible time in minutes required to reach hypotenuse from A at the speed of 30 kilometers per hour. So right angle triangle, BC is the hypotenuse. So A is the point where the angle is 90 degrees, B, A, C. This has been given to me as 15, this has been given to me as 20, and I want to go from A to BC in the shortest possible time. Guys, shortest possible length is a straight line, and to be precise, a perpendicular line. So basically I want to know perpendicular on the hypotenuse. If this is 15, the next side being 20, they are in the ratio of 3 by 4. So the third side must be in the ratio of 5. This is 5 times 5 times, this has to be 5 times. So 25 is the hypotenuse. Now, see, whether I use this as perpendicular and this as base, or I use this as base and this as perpendicular, it is the same triangle, same area. This gives me the length AD into 25 as 15 into 20. I get AD as 5 cancelled, 5 cancelled. AD as 12 kilometers. Now 12 kilometers if you travel at a speed of 30. The question was in minutes. What I have right now is kilometer per hour. So I've got time in hours. So multiply it by 60 to convert that in minutes. So it will take a minimum of 24 minutes. The property to learn or apply here is this. I can put this property in a formula format for you. Perpendicular, base, hypotenuse, language. Please focus on the language. Perpendicular on the hypotenuse. Perpendicular on the hypotenuse is P into B by hypotenuse itself. So if you remember this, you can solve this pretty fast. There is one more property that is useful in such questions, that is, as I had said, I'll give you some extra properties. If this length is x and this length is y, if the lengths are x and y are given, in that case, the perpendicular on the hypotenuse is of the length root over x into y. We don't have time here to prove these properties. You can visit one of my other lectures based on lines and triangles. There I have proven these properties. You can take it up from there. Let us try another problem. Let A, B, C, D, E, F be a regular hexagon with each side of length 1 centimeters. The area in square centimeter of square with AC as one of its side. AC as one of the sides. Alright. So I hope you guys are not too much distracted by this time. We are at the 14th problem. We have 41 problems like this. So we are 1/3 way into a session. A, B, C, D, E, and F. We want to use AC as the one of side of the squares. These are all 1, 1, 1, 1, 1. So if I can find AC, I can simply square it. I will have area of the square. Now this angle is 120 for a regular hexagon. These angles are 30 and 30. So we have talked about this multiple times by now. 30, 30, 120 ratio is 1 ratio 1 ratio root over 3. So if these are 1 and 1, this one has to be root over 3. So if that is root over 3, the area is square of it. The question was find the area in square centimeters of the square with AC as one of its sides. AC as its side. So if side is root over 3, the square is 3, that is the answer. This line AC, this line AE, and this line AD. They are all equal. These are called alternate diagonal or alternate point diagonal in a regular hexagon. They are all equal. They form a equilateral triangle. There is one more property that you can use further. The area of the triangle AEC is half of the area of the hexagon, or area inside is equal to area outside, and these areas are also equal. Let us continue with this. Maybe in between I'll take a break and then I'll split the session in two, or maybe I'll merge this and I'll make it one big session, because you guys need to develop patience to sit in one place for 3 hours and 30 minutes, 3 hours and 40 minutes. And quant is the last section, guys. So you have to develop that patience. That is why we ask you to appear mocks, appear 30 mocks, appear 50 mocks. Some people appear 70 mocks. These are the toppers. Your hunger decides how far you want to go into the battlefield. Let us try the next problem. Base of a vertical pillar with uniform cross section is a trapezium whose parallel sides are of the length 10 centimeters and 20 centimeters, while the other two sides are of equal length. The perpendicular distance between parallel sides of the trapezium is 12 centimeters. Height of the pillar is 20 centimeters. The total area in square centimeters of all 6 surfaces of the pillar is. Alright. Again, a 3-dimensional geometry based question. The difficult part here is being able to faithfully represent the information as it is presented. I have got a trapezium, and when I vertically project that, see, some slight errors in drawing are fine. If I vertically project that, if I join this here, if I join this here, I'll not be drawing this rangoli very clearly here. One of the length is 10, the other length is 20, and the height, see, I'm changing the color here. Here, this is the height. This is the height, that is 12. Observe. If this is 20 and this is 10 and the trapezium is isosceles, that means this is 5 and this is 5. I'm working with a 2D structure. This trapezium I'm working with. So 5 and 12 form a right angle triangle with 13. That means the non-parallel sides are 13. Now, what is required of me? Find the entire surface area of the pillar. So I'm looking at two trapeziums. What is the area of a trapezium? Half the sum of parallel sides multiplied by the height. So this is the area of the upper and the lower surface. Then I'm looking for 4 walls. See, the height of this wall is 20 and the base of the wall is 10. So 10 into 20 is the surface area. The base of this wall is 20 and the height is also 20. So the area is 20 into 20. So there is one wall of this kind, there is one wall of this kind. Now this base 13 and height 20, I have got 2 walls. So guys, this is the answer I'm looking for. If you are in a hurry and you're not very confident of calculations, use a calculator if you have to. This is 30. This half and half is cancelled. 30 into 12 is 360. This is, I'll write in a vertical manner, 200, 400. And this is 26 into 20. That is 520. So I have got 80 in the end. And this is the only answer option with 80 in the end. So if you are sure of your steps, your answer is ready. If you want to verify, 3 plus 2, 5, 5 plus 5, 10, 10 plus 4, 14. That is our answer. What is exam trying to test here? Can you visualize the structure? Otherwise, these are very basic properties. Remember the triplet 5, 12, 13. And that's it. Apply formula for areas and add it up. Let us continue further. ABCD is a quadrilateral inscribed in a circle with center O. COD is 120 degrees, BAC is 30 degrees, then what is the value of BCD in degrees? Let me try to plot this properly. This is the circle with center O. and we have a quadrilateral with vertices A, B, C, D. O is the center. Now what degrees are given to us? COD. COD is 120 degrees. Angle BAC. See, if I join this line here, angle BAC is given to us as 30 degrees. The question is, can you find angle BCD? We want this complete angle. Now, let me apply the property of angles formed inside a circle. The angle formed at the center by the chord, if I imagine CD is the chord, this angle is double of what will be formed here. This line CA and this line DA complete the triangle CDA. The angle formed by the chord at the center is double of the angle it will form at the perimeter of the circle. So if this is 60, this is 30, this complete angle is 90. And the property of cyclic quadrilateral says opposite angles add up to 180. So angle CBD is equal to 90 degrees. That is answer option A. No heavy calculations are required. All you need to know is, in a circle, if you have a chord, the angle formed at the center of the circle by the chord is 2 theta, and angle formed by the chord at any other point on the same side is theta. And if you need more properties, angle formed on the opposite side by the same chord is 180 minus theta. Some revision of properties. Soon I'll be uploading a session on theory of circles as well. So I'll cover these properties in detail there. So far, I think you can see a session on lines and triangles and a complete session on quadrilaterals and polygons. In session of polygons, in the part of polygons, I have covered hexagons, regular hexagons and octagons in detail because these are the most common polygons asked in CAT. Let us continue. Three sides of a rectangular park have a total length of 400 feet. Then area of the park is maximum when length in feet of the longer side is. Alright. Three of the sides total are 400. So if this is side A, this is side A, this is side B, I have been given 2A plus B as 400. Because it is a rectangular park, obviously the missing side has to be equal to B. No logic required there. I have been asked to find the longer side if area is maximized. Now here, some understanding of maxima minima is necessary through point of view of algebra. See, we say arithmetic mean of numbers is more than or equal to geometric mean of numbers. See, the question is not to find the area. Now, this inequality works when these terms are made equal. So, if I make 2a is equal to b, I get b is equal to 200 and a is equal to 100. Guys, the concept of AMGM working is relying on this property, that terms must be made equal. Not a is equal to b. 2a is equal to b needs to be made. So the longer side turns out to be 200. This is at this stage not going to be covered in detail as a theory. You can simply work this out. You can copy down this property and later on when you cover algebra, you can verify these results. P is an interior point of a right-angled isosceles triangle ABC with hypotenuse AB if perpendicular distance of P from each of the AB, BC, CA is 4 times root 2 minus 1, then area in square centimeters of the triangle ABC is. This looks like a problem that will take some time. Let us check. Let us see. We have been told that the structure is right angled. No sides are given to us. Isosceles has been mentioned. Good thing. Isosceles has been mentioned. And there's a point P inside. AB is the hypotenuse. And this is the 90-degree point. Now, this is at the same distance from all the given sides. Guys, that is called in center. If a point inside is at the same perpendicular distance from all the sides of the triangle, that is the in center. And this length is in radius. So, for right angle triangle, the in radius is given by perpendicular plus base minus hypotenuse by 2. Now, here's a critical hint. If you remember and recall this question should not take more than 2 minutes. If you do not remember this, you'll have to take the longer route here. The isosceles triangle has sides as x, x and root over 2x. Here I get 2x minus root over 2x by 2 as the in radius, which is 4 times of root 2 minus 1. Now please pay attention to calculations here. Here I can take out x common. I can take out root 2 common. I will have root 2 minus 1 upon 2 and 4 into root 2 minus 1. So root 2 minus 1, root 2 minus 1 cancelled. This cross multiplies. X is equal to 8 upon root over 2. What do you want? You want area of the triangle. So half base into height. So 64 upon 4. That is 16 units is the answer. Now again guys, being able to recall this is critical. If you do not go along this path, you'll have to go along the path R is equal to area of the triangle upon semi-perimeter of the triangle, and from this reach the same conclusion to find the side. Once you find the side of an isosceles right angle triangle, answer or area is ready. Let me give you one additional result here. If you want to have a circumcircle, for right angle triangle, the circumradius is half of the hypotenuse and circumcenter is midpoint of the hypotenuse. I'm giving you this as an additional property. It is not useful in this particular problem. For any right angle triangle, midpoint of the hypotenuse is the circumcenter and half of the hypotenuse is the circumradius. You can use this further as a standard result anywhere. Now, that ends our question or set of questions from CAT 2017. We are starting with questions from CAT 2018. If you need a break, pause this video, take a break of a few minutes and then come back. I'll continue with this. Question number 19. In a circle, two parallel chords on the same side of the diameter have lengths 4 and 6 centimeters. The distance between the chords is 1 centimeter. Then radius of the circle in centimeters is. See, I highlighted on the same side because I could have drawn the structure in two ways. Center lies between chords. Center lies on the same side of chords. Here it says center lies on the same side of the chords. So let me draw this properly. Let us say this is one of the chords and this is another one of the chords. Yeah. And let us say this is a center. Now, this is the radius R. This is the radius R. The distance between these, this is 1. And if the lengths are 2 and 6, half of that will be 2 and 3. Why are we going with 2 and 3? Because perpendicular from the center bisect chords. Now, I am looking at two triangles with parallel base and the distance between them being 1. So I can solve this through similarity, or if I call this length simply as x, I can say x square plus 3 square is equal to r square, and x plus 1 square plus 2 square is equal to r square. If I equate both, I will have x square plus 9 is equal to x square plus 2x plus 1 plus 4. I am simply equating and removing r here. This is gone, this is gone. This is 5. When subtracted here becomes 4. So 2x is equal to 4. I get x is equal to further 1. If x is equal to further 1, now the radius can be found with any one of the structures. Here, this is 3, this is r, and this is 1. So 3 square plus 1 square. Did you make a mistake in calculation here? This is 5 cancel, x is equal to 2 guys, x is equal to 2. So 3 square plus 2 square, that is 9 plus 4, 13, in the square root is the radius. Let us try another problem. Let ABCD be a rectangle inscribed in a circle of radius 13 centimeters. Which one of the following pairs can represent in centimeters possible length and breadth of ABCD? Looks like a fairly simple problem. For a circle and a rectangle as well as square, if you plot in this manner, guys, diagonal is the diameter. So if this is 26, which is 2 into 13, if the sides are integers, this has to be 2 into 12, 2 into 5, or vice versa. So 24 and 10 can be the other two sides. Imagine this kind of question coming in CAT. Recall, the first problem we started with was also based on remembering Pythagorean triplets. A lot of times people say, sir, कितना रटना पड़ेगा to clear CAT? बेटा जितने नंबर चाहिए, जितना अच्छा कॉलेज चाहिए. If you feel bad about mugging up, mug up these values and then feel bad for a couple of days. Don't eat anything, you lose weight. Just kidding, guys. Points E, F, G, H lie on sides of AB, BC, CD, DA respectively of a square ABCD. EFGH is also a square whose area is 62.5% of that of ABCD. CG is longer than EB. Then the ratio of length of EB to CG is. Now, I think there is some hint hidden here about the longer side. Something is there. Let me start with the plotting of the square. Imagine this is the square. Here. This is our square. In this square, I am going to plot another square. A, B, C, D. The area of the inner square is 62.5% of area of the outer square. These are named EFGH. So we are being told CG is longer than EB. That means E is closer to B and G is away from C. In this manner, if this is close, this is close, this will be closer, this will be closer. Let us call this F, and this will be closer. Let us call this H. So here what you are getting is a square. Pardon my drawing here. This inside structure is a square. The question is find the ratio of EB upon CG. So if this is X, this is X, this is Y, this is X, this is Y, this is X, this is Y, and again, I think I have missed the orientation somewhere, but you get the idea here. This is X, let us say this is Y, this is Y. X, Y, X, Y, so something of this nature is there. You want the ratio of EB to CG. Maybe I have misplaced the orientation. Let me work with the areas here. See, the area of the inner structure EFGH when divided by area of ABCD, it is 62.5%. Guys, remember ratios. This is 5 by 8. Now please pay attention. Because I'm working with squares, let me multiply both with 2. This gives me this side as 4, this side as 4, this side as 4. I'm working with assumptions here. And the internal area is 10. That means the outer area is 6. Observe, half of x into y made 4 times is 6 in my assumption. So x into y is 3 and x plus y is turning out to be 4. Basically, somehow I'm looking for x and y ka ratio. Look at these answer options. Which of these answer options multiply up to 3 and add up to 4? Answer option D. The best thing you could have done here is this assumption. Why? A square will have a square area if the sides are integers. 62.5% is 5 by 8. This part requires understanding of percentages. So see, if I'm good with percentages, this helps me here. Pay attention. I did mess up the orientation of x and y in some manner, but basically I am looking for, because had it been equal, answer would be 1 by 1, not there. So I'm looking for x by y ratio, and here I don't have to solve any further because I assumed a proper value 16. Denominator was 8. I was looking for the closest square available to me. 22nd problem, guys. We are midway through our session here. We have equal length of time to cover. Now, what is being said here? Given in an equilateral triangle T1 with side 24 centimeters, a second triangle T2 is formed by joining midpoints of sides of T1. A third triangle T3 is formed by joining midpoints of sides of T2. If this process of forming triangles is continued, the sum of areas in centimeter square or square centimeter of infinite such many triangles T1, T2, T3 and so on will be. Alright, so I see a equilateral triangle being plotted. That triangle is called T1. In that triangle, I am going to join midpoints. Imagine the midpoints. The inner one is going to be called T2. Now observe. See, I am calling the area of T1 to be A. We'll come back to the properties. We'll come back to these values. When you join midpoints, the midpoint theorem says there are 4 equal areas created. If you join midpoints for any triangle, not only equilateral, for any triangle, if you join midpoints of sides, you get 4 equal areas. That is midpoint theorem. So the area becomes A by 4. If I join further midpoints, area becomes A by 16. Further, A by 64. This is called a infinite GP. So I'm going to add A by 4, A by 16 up to infinity. This is sum of all areas. So guys, the formula for infinite sum of infinite GP is first term upon 1 minus the common ratio. What is the common ratio? From here it is 1/4, here it is 1/4. So 1 minus 1 by 4. That gives me A into 4 by 3. Now I'll go after A. What is A? Area of a equilateral triangle. What is area of a equilateral triangle? Root 3 by 4 side का square. ये area हमारा A है. Multiply this with 4 by 3. So this is gone. This is gone. What do we have is 24 का square divided by root 3, or y divided by root 3. This is cancelled. This is cancelled. 8 times 20 into 8 160, 4 into 8 32, 192 root over 3. Now what is required here? you must know something called as midpoint theorem. You must know how to find sum of an infinite GP. I'll cover that part one more time here for you. Sum of infinite GP is given by first term upon 1 minus the common ratio. If you know this property, this should be a walk in a park. Next one. A right circular cone of height 12 feet stands on its base, which has a diameter 8 feet. The tip of the cone is cut off with a plane which is parallel to the base 9 feet from the base with pi is equal to 22/7. The volume in cubic feet of the remaining part of the cone is. Now a cone is being cut off at some distance from the base. So guys, you are dealing with a frustum here. See, when you look at a cone in a cross-sectional manner, you're looking at a triangle. The base of the triangle has a diameter 8. So here, this is 4 and this is 4. The height of the triangle that you have is 12. That is height of the basically cone here. Height is 12. Now, 9 feet from here, a cut is being made. If you make a cut 9 feet from here, you're making cut 3 feet from here. See, 3 upon 9 or 3 upon 12. 3 upon 12 is 1/4. So you are dividing the height in 1/4 from this tip A. If I look at the smaller triangle and if I look at the bigger triangle, they are similar and the ratio of sides is 1/4. So if this is 4, this is going to be 1. So can I say volume of the remaining portion? Observe. Volume of the remaining portion of the cone, which is called frustum, should be volume of the total structure minus the smaller cone. The smaller cone I have got the height, I have got the base. The total cone will have volume of 1/3 pi r square into h minus 1/3 pi r square into h. Again, I am applying similarity of triangles here to solve question on frustums. What I am doing is from the total cone, from the bigger cone, I am taking away the smaller cone volume. So let 3 be there. What is wrong with this? Let there be 3 pi. This is 16 into 12 minus 3. 16 into 12, 16 into 10, 160, and then 32, that is 192, minus 3 is 189 pi by 3. I think this was a data based question and question expects us to put the value 22/7 here. 189/3 into 22/7. So you guys can perform this calculation further. Let us move on from this. Theta questions come with statements very clearly telling you how to type the answer. Should the answer be in the form of pi, then it will be as in the form of a pi. Simply type a, or you type the entire answer with decimals with 2 decimals correct. Such instructions are given with theta based questions. Type in the answer theta. In a parallelogram ABCD of area 72 square centimeters, sides CD and AD have lengths 9 centimeters and 16 centimeters respectively. Let P be a point on CD such that AP is perpendicular to CD. Then area in square centimeters of the triangle APD. I'm finding it slightly difficult to visualize here. Let us say this is our parallelogram. Among the sides AD and CD, AD is the longer one. So A, B, C and D. CD is 9, so AB is 9. AD is 16, so it also is 16. Now here, where is P? P is a point on CD such that AP is perpendicular to CD. So guys, obviously because I'm assuming this manner, it appears to me, I will have to draw CD outwards and there I will have to put a perpendicular. Here, let us imagine this is the perpendicular AP. Now we have the area of the structure as 72 square centimeters. Now very clearly area of a parallelogram is perpendicular multiplied by the base, that is in this case equal to 72. I directly get the value of AP as 8. This AP is 8. Now this is 16. Please pay attention. This is 16. Now I can apply squares and get my answer for PD and get the answer further. Why would I want to do that? See, 8 and 16 are in the ratio of 1 by 2. That is part of 1 ratio root 3 ratio 2. 1 and 2. 2 is the hypotenuse. 1 is the 8 part, which is 30, 60 and 90. So if this is 16, this is 8, this one must be 8 root 3. So DP is 8 root 3. So what is the area of the triangle APD? Half of base into height. So 64 by 2, 32 root 3. See, again, I'm able to come across such ratios again and again. I see the hypotenuse is double of one of the sides. That is 30, 60, 90. Let us try and finish the class sheet in one sitting. A set of questions in one sitting. In a circle with center O and radius 1 centimeter, an arc AB subtends an angle 60 degree at O. Let R be the region bounded by radii OA, OB and arc AB. If C and D are 2 points on OA and OB respectively such that OC is equal to OD and the area of the triangle OCD is half of that of R, then length of OC in centimeters is. Now this looks like a very elaborate problem. Let me first start with a circle. Guys, you need to draw diagrams big enough so that you can draw further lengths in those. Now guys, I assume that you can visualize a circle here. This is the center O, then there's a length OA and OB. Guys, this entire area is being called R because this angle is 60. This AOB thing is a sector with 1/6 of the angle. So the area of that sector will also be 1/6 of the circle. 6 pi is the region R. Now there is a point C here, there's a point D here, and then a triangle has been formed. This triangle has the area which is half of this R. Now here, because you are drawing this by joining 2 points with 60 degrees, these will also be 60 degrees. You are working with an equilateral triangle here. So if I assume this length to be x and this length to be x and this length to be x, we know that the area is given by root 3 by 4 x square. That is the area of OCD. This has been given to us as the area of OCD is half of the region R. In this way, find the value of side OC. Side OC is x. X is equal to 4 by root 3 into pi by 12. So cancel 3. ये square था. This will give me x as pi by 3 root 3 cos square root. Again, here I need to know how to find area of sector. Area of sector is theta upon 360 into pi r square. And equilateral triangle area, I think we are applying here for the third time or maybe the fourth time. Area of an equilateral triangle is root 3 by 4 side ka square. Let us continue with this. Answer option C, guys. Answer option C. Keep verifying your answers. A parallelogram ABCD has area 48 square centimeters. If length of CD is 8 centimeters and that of AD is S, then which of the following is necessarily true? And answer options are in the form of S is not equal to 6, S is more than 6, S is between 5 and 7, S is less than 6. Basically, the question is about either you find the length S or you find the range for S. Again, I have been given a parallelogram and I need to convert the area format here into a range or a value. A, B, C, D. CD is 8, so AB is also 8, and AD is S. See, my S looks like 5, so I'll call it X. Let us call it X. I'm working with X. Now I need to convert this question in the range of X or find the value of X. Now, one way that I know of, area of a parallelogram is also given by product of sides into sine theta as 48. That gives me X is equal to 6 upon sine theta. Now theta, sine theta is between 0 and 1. That means the denominator is less than 1. So when you divide 6 by a number less than 1, X will become more than 6. So it appears to me that S in this case is more than equal to 6. Now guys, these methods that you are seeing, again, this question is from CAT 2018 afternoon slot. I remember appearing this paper, I remember solving this problem there. In my last 5 CAT attempts, I have scored 99 percentile and plus every time in quant. I apply these methods, I test these methods every year. My highest score was 99.97 in CAT 2018 paper. This was the paper I was solving. This is the paper I was discussing with you. These methods are very effective. You can test these methods in your current mocks. A chord of length 5 centimeters subtends an angle of 60 degrees at center of a circle. The length in centimeters of a chord that subtends an angle 120 degrees at the center of the same circle is. Because length has been, angle has been doubled, most people will say length will be doubled. And guys, there are no answer options with twice the value. So no, you are thinking on the wrong lines. In the circle, there's a chord that subtends the angle 60. If this is the chord and the angle here at the center is 60, then these are also 60. That means length of the chord and radius of circle are equal or is equal because it forms an equilateral triangle. Now imagine a chord, if it subtends the angle 120 at the center, that means it will subtend the angle 30 and 30 here. So this is 5 and this is 5. Now recall the property, guys. 30, 30, 120 ratio is 1 ratio 1 ratio root over 3. So if I make this 5, this will become 5 and this will become 5 root over 3. The question was, what is the length of the chord that subtends the angle 120 at the center of same circle? That will be 5 root over 3. Answer option A. Again, for the fourth time, you are applying this ratio 30, 30, 120. Why not? What does it say? Area of a rectangle and the square of its perimeter. Okay. Area of rectangle and the square of its perimeter are in the ratio of 1 ratio 25. Then lengths of the shorter and longer side of the rectangle are in the ratio. You are telling me that area, length into breadth, and perimeter ka square, that is twice of L plus B squared, is 1 by 25. You want to find out which of the following can be length and breadth ka ratio. Go with answer options. If it is 1:4, the area is 1 into 4 divided by 1 plus 4 का double is perimeter, perimeter का square. So 4 upon 4 into 25. Why would you want to solve this question by cross multiplying and then squaring and then dividing? Simply, area is length into breadth, rectangular structure, perimeter is twice of length plus breadth. I want perimeter ka square, that is 25 here. First answer option fits everything. Even if the last answer option fits the criteria, I'll still check. Still better and faster. Next one. On a triangle ABC, a circle with diameter BC is drawn, intersecting AB and AC at points P and Q respectively. If length of AB, AC and CP are 30, 25 and 20 respectively, then the length of PQ in centimeters is. Again, options are not given to us. This is a theta based question. Let us be careful. In a theta based question or type in the answer based question, you cannot be sure of the answer. That is where a lot of people freak out. I am getting the hint here that BC is the diameter. So if I say this is BC, looks like a diameter, BC, this is going to intersect the triangle ABC at some points. Guys, use your imagination, the straight line. It intersects them at points P and Q. Now some hints are given as to these values. We have AB as 30. We have AC as 25 and CP guys, CP is given to us as 20. Now the property that I can think of here is again the length of BQ is required. Now the property I can think of here is the diameter subtends the angle 90 degrees on the perimeter of the circle. So indirectly I have just now received the perpendicular CP on the base AB. By same reasoning, BQ will be perpendicular on AC. So what do I have here? I have got two sides and two perpendiculars on those sides. This gives me idea it is the same triangle. That means half of base into height should be same as half of base into height. So half is gone. 5, 4, 6. So 24 is equal to BQ. Again, if you do not recollect this property, solving this will be very difficult, guys. What is the property here? Diameter of a circle subtends the angle 90 degrees on the perimeter of the circle. We are nearing the end of this session. Just 12 more problems to go. Nothing heavy, nothing you guys have never done before. Pretty mundane. A triangle ABC has area 32 square units and its side BC of length 8 units lies on the line x is equal to 4. The shortest possible distance between A and the point 0, 0 is. What I see is a question based on coordinate geometry. If possible, I'll cover the same problem again when or whenever I get a chance to create a session on coordinate geometry. These are my xy axes and this is my line x is equal to 4. Guys, this one is x-axis, this one is y-axis, this is the line x is equal to 4. Now I have to put a length BC. See, if I put BC here and if I put A here, the distance from A and the origin is to be measured. To minimize the distance between A and origin here, would it not be best if I could simply put BC here? If this is BC, the total length was given to me as 8. So this is 4, this is 4, the complete length is 8. In this way, because the structure is symmetric on both sides, it is basically either an isosceles triangle or an equilateral triangle, either. This is A. What is the area given to me? 32 square units. So from A to this length, I'll have perpendicular, half of perpendicular into base is equal to area. Area is 32 square units. So cancel 4. So perpendicular is 8. Now please pay attention. This entire distance is 8. This distance is 4. That is what coordinates tell us. X is equal to 4 was the length here. So this is 4, this will be 4. So shortest distance between A and O is 4 units. I hope this makes sense. I tried to make the structure symmetric to minimize the distance of A from O. What does this question say? From a rectangle ABCD of area 768 square centimeters, a semicircular part with diameter AB, area 72 pi is removed. What is the perimeter of the leftover portion? Okay, so let me first draw a rectangle. We have not been given dimensions of the rectangle here. Let us imagine this is A, B, C, D. See, this might not be drawn to the scale. With AB as a diameter, you are going to cut away a semicircle. So what remains is this, 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 and this needs to be found, guys. This needs to be added. That is the perimeter of the leftover structure. I see one thing peculiar here. The pi part is not equal for any of these answer options. In fact, this part is also not equal, the integral part. So I can answer it through either integral or pi. If you tell me the area of this part is 72 pi, that means area of the complete circle should be 144 pi. 144 pi is equal to pi r square. So this cancelled. R is equal to 12. If r is equal to 12, this is a semicircular part. So the perimeter will be half of the total. That will be pi into r. So this arc A and then up to B is 12 pi. Only option with 12 pi is C. Now this brings us to the end of questions from CAT 2018. So we have completed CAT 16, CAT 17 and CAT 18 problems. Remaining is CAT 2019. Corners are cut off from an equilateral triangle T to produce a regular hexagon. The ratio of area of H to that of area of T. Here I have been told that the triangle is equilateral. You and I are going to cut off corners. By cutting off these corners, we want the remaining portion to become equilateral or become a regular hexagon. See, if this is X and this is X and this is X, this tells me these are also X. Now, I can take any of the roots. I can apply the symmetry property and common sense with areas, or I can go to the root of formulas. Both are going to work here. See, hexagon area is given by 3 root over 3 by 2 side square divided by Triangle, because sides are 3x, the complete side is 3x. For equilateral, the area is root over 3 by 4 side cos square. So not a very big deal. If you remember these formulas, again 10 seconds our answer will be ready. X square is gone, this becomes 9, and root over 3 is gone, this is gone 2 times, this 2 goes up, 2 into 3 by 9, cancel, 2 by 3 should suffice. Now, what other way can I apply in terms of symmetry? See, in hexagons, you'll find that in the session of quadrilaterals and polygons, if the side is x, for any regular hexagon, you will have 6 equal areas inside. So if you tell me about the bigger triangle, I have 9 equal areas. 1, 2, 3, 4, 5, 6, 7, 8 and 9. Out of these 9 areas, there are 6 areas inside the hexagon. So that is again 2 by 3. This property of symmetry, if you can think in terms of, this will take further 10 seconds. If not, you can recall these formulas and perform these calculations. Again, let me cover this one more time. Area of a regular hexagon is 3 root over 3 by 2 side cos square. If you can recall this, this should not be a problem. Next one. AB is a diameter of circle of radius 5 centimeters. Let P and Q be 2 points on a circle such that length of PB is 6 centimeters and length of AP is twice of AQ. Okay. Then length in centimeters of QB is nearest to. So requires a circle. What is AB? Diameter. AB is the diameter. What are the hints? P and Q are the 2 points of that. PB is 6 and AP is twice of AQ. Alright. Let me take P here. Let me take Q here. PB is 6. This is what? This is diameter 10. Now, we have covered this property a few minutes back. This angle will be 90. 6, 8 and 10 form a right angle triangle. We have been told that length of AP is twice of AQ. So AQ guys will be 4. And the question is, can you find BQ? Now 4 square plus BQ square is equal to 100 because this angle is also 90. So BQ is equal to 100 minus 16 ka root over. That is 84 ka root over. And this will be 9 point something. Only one answer option. अगर और answer options होते भी, you have ये रहा एक और answer option. You have access to calculator. Now guys, be careful. These are close. Use a calculator here. I do not have a calculator on the screen. Root over of this, you can find out with the calculator. If you want, I'll perform a square on these and get you the answer. See, 91 ka square is 8281. 93 ka square is 86 something. So guys, the closest one looks like this. Still, use the calculator guys. Don't go with my calculation, use the calculator. I might be making a mistake with squares here. Next problem. If rectangular faces of a brick have their diagonals in the ratio of this 3 ratio 2 root 3 2 root 3 ratio root 15, then the ratio of length of the shortest edge to that of the longest edge. Alright, I see something new here. These are diagonal ratios. See, if I imagine a brick with dimensions A, B and C, then diagonals will be root over A square plus B square, root over B square plus C square, root over C square plus A square. These are given to me as 3 ratio 2 root 3 ratio root over 15. By solving this, if I can find A ratio, B ratio, C, my job is done. I will find the smallest and the largest one. So before I proceed any further, I prefer performing squares here. I will have A square plus B square as 9, B square plus C square as 4 into 3, 12, and C square plus A square as 15. Now, I can find A, B, C. The safest way forward is add all three. You will have twice of A, B, C, A square, B square, C square, and subtract further. Or I can subtract these two. I will have C square minus A square as 12. If I add both, A square as 3. This is 2C square is equal to 18, C square is equal to 9, C is equal to 3. If C is equal to 3, C square will be 9, A square will be 6, so A is equal to root over 6. If C square is equal to 9, C square is equal to 9, B square is equal to 3, so B will be root over 3. So which is the smallest one and which is the largest one? Smallest one is root over 3, largest one is 3. What is root over 3 ratio 3? It is 1 by root 3. Answer option A. Again, this question involves that I understand the properties of ratios here. If I can work with ratios faster, I saw a cyclic pattern. One of the effective ways of solving a cyclic pattern based question is you add all and then perform the plus minus part. I simply subtracted the first two. I got C square minus A square as 3. I added the next two. I got C value, I got A value, I got B value. The question was find the shortest and the longest side ka ratio. Let us go further from here. We are nearing end, guys. We are nearing end. It's almost 2 o'clock. That is 2 a.m. at my end, almost. In a circle of radius 11 centimeters, CD is diameter, AB is a chord of length 20.5 centimeters. If AB and CD intersect at a point E inside the circle, CE has the length 7. Okay, the difference in lengths of BE, AE in centimeters is. Okay, sounds like an elaborate problem. A lot of sides and diameters are going on here. Let me first plot this. Again, this is the circle I've got. CD is the diameter. So let us say this is the diameter CD. The radius was 11. So I've got CD as 22. See, I'm keeping length outside because I'm going to plot a lot of lengths here. What does it say? And AB is the chord with a length of 20.5. Okay, let us say this is, because this is less than 22.5, is away from the center. This is center. Let us say O. Let us say this is AB. Intersects at the point E inside the circle. Now CE is 7. If CE is 7, this is 22. This must be 15. What do we want? We want the difference between the lengths of BE and AE. I am calling BE as X and I am calling AE as Y. Now this property involves length of chords. The property is X into Y would be 7 into 15, which is 105. And I have got X plus Y as 20.5. The question says, can you find the difference? I can think of a method as X minus Y square is equal to X plus Y whole square minus 4 times XY. And you have access to a calculator in exam. You can put values and get your answer faster here. Or I can think of a hit and trial approach here. I see a pattern here. Here and here. There's a 0.5. All the answer options have 0.5. So one of the value has 0.5 in the end and the other value is an integer. I feel like I can generate this with 10.5 into 10 and I can generate this with 10.5 plus 10. So these values match every parameter, 10.5 into 10 and 10.5 plus 10. That tells me the gap between X and Y is 0.5. If you do not want to take this risk, if you are not able to catch up with these decimal parts, This is the approach forward. X plus y is 20.5 whole square minus 4 into 105. This is equal to x minus y ka square. You have a calculator in the exam on the screen. You can calculate this from there. Let us continue with this. In a triangle ABC, AD and B are medians. AD and D are perpendicular to each other and they have lengths of 12 and 9 cm respectively. Find the area of the triangle ABC. Okay, it does not say what kind of triangle we have, but medians are perpendicular. If this is the triangle ABC, median AD. See, medians are not perpendicular, guys, on sides. They are perpendicular to each other. This line here is the median. Let us call this AD and another is BE. Guys, these angles are 90. You might not feel, but these are 90. We have been told that one of the length is 12. AD is 12. BE is 9. What is expected from us? That we'll do something and find the area of triangle ABC. Now, the point where medians cross each other is called the centroid, denoted by G. And the property of that is it divides the length in 2:1, 2 being towards the vertices. So here the length BG is basically 2/3 of 9. That gives me length 6. This length here is 6. This length GD is basically 1/3 of 12, which gives me 4. Now here I can find the area of the triangle BGD as half of base into height. Now recall this, we have talked about a couple of times by now. If I draw one more median like this, there are 6 equal areas created. This is one of those areas. So making it 6 times further is the answer to our problem, area of triangle ABC. So what I have is 6 cancelled by 2 is 3. 24 into 3, 72 is the answer. Again, what did we apply? Property of centroid. Centroid divides the median always in 2:1. The longer length is towards the vertices. Now what do we have here? Two circles, each of radius 4 centimeters, touch externally. Each of these two circles are touched externally by a third circle. If these three circles have a common tangent, then radius of the third circle in centimeters is. Okay, these are very touching circles, guys. One circle, another circle touch each other externally, and there's a third circle which is touching these two, and they have a common tangent as well. The question is, can you find the radius of this? See, I can give you a formula for this. I'm not going to give you the formula here. I'll let you guys research that. Or when I upload the session on circles, I'll give you that formula. Here I'll give you the proper method. Whenever you come across touching circles or circles touching straight lines, try to create triangles and try to find sides. See, radius of each one of these is 4. So this length is 8. This is 4. This is 4. Please pay attention now. Here, this is small r plus 4 and this is small r minus 4. Observe. This is 4 from center to the point of contact here. This is small r minus 4 and this is small r plus 4. This is small r and this is radius 4. This is height 4. So performing squares here should give me my answer. So I have r minus 4 square plus 4 square is equal to r plus 4 square. The question was radius of the third circle. That is what we need. I think there is something wrong with these answer options. Answer option should not be in ratios. Let me see. Acha, pi by 3 and by root 2. Let us see. Here I have r square minus 8r plus 16 is equal to r square plus 8r plus 16. 16 is gone. R square is gone. This 8 and this 8 make it 16r is equal to 16. So I'm getting r is equal to 1. Answer option B. Try to connect these centers. You will have r and r related with a right angle triangle. Easier to solve. What do we have here? Base of a regular pyramid. Let us see, is a square. Each of the other 4 sides is a equilateral triangle, length of each being 20 centimeters. The vertical height of the pyramid is. See, we are saying it is a square pyramid. This is our second problem on pyramids. We have solved one earlier. You can rewind the session and check. We have 4 sides as equilateral triangles. That means the base and these triangles have same length. See, this base is a square. It has a length of 20. Now, I do not know what is this vertical height. I do not know what is this vertical height. That is what I'm trying to find here. Now, if I can find the slant height, I can find the vertical height because this will be 10. This will be 10. This I do not know. This I do not know. Now, imagine a equilateral triangle that is going to be one of the surfaces here 20, 20, 20 and the perpendicular. See, I know the formula, but here let us try and get that. This is 60, this is 90, this will be 30. Now, if I recall 30, 60, 90 ratio, it is 1 ratio root 3 ratio 2. Opposite to 90, it is 20. This is 20. This will be 10, this will be 10 root 3. So this is 10. This will be 10 and this will be 10 root 3. Now what is this height? This height is this one. This one. This one is 10 root over 3. Now this is 10, this is 10 root 3. What do I want? I want this height here. So 10 root 3 cos square is equal to 10 square plus height cos square. The root 3 square is 3, so I have got 300 minus 100, 200 is equal to h cos square. So h is equal to 10 root over 2. Answer option A. Please pay attention, how did we achieve this? See, if I look at this from any of the sides, I'll be looking at equilateral triangles. For this triangle, I found out the slant height. That slant height is this one. I'll highlight this with red color here. I found out this line. I found out this line, this height, this one, red one. With that, I perform Pythagoras theorem. I apply Pythagoras theorem and I got my answer further. Let us continue, guys. We have 2 or 3 more problems. Let's finish this thing. I hope some of you have managed to stick till this point or till the end of the session. CAD people are going to test your patience. Let A and B be 2 regular polygons having sides A and B respectively. If B is equal to 2A, each interior angle of B is 3 by 2 times each interior angle of A, then exterior angles in degrees of regular polygon with side A plus B. Okay, with A plus B sides. तो पहले तो A और B की बात कर लेते हैं. जो polygon होता है regular, if you want internal angle, it is n minus 2 into 180 by n. Here, if the side is A, number of sides is A minus 2 into 180 by A. This is the one interior angle of polygon A. 3 by 2 times of this is one interior angle of polygon B. So here I directly get a hint. I can cancel out A, 180, 180. This 2 and this 2 is also gone. What I have here is 3A minus 6 is equal to 2A minus 2. Transferring this, I'll have A is equal to 4. If A is equal to 4, B is equal to 8, what do you want? You want external angle of a polygon with sides A plus B. So there are 12 sides. So external angle is 360 by 12, that is 30 degrees. Please pay attention. You want another regular polygon with number of sides as A plus B. So I'm able to get A is equal to 4, B is equal to 8. So the polygon with A plus B sides will have 12 sides. And one outer angle is given by 360 by n for regular polygons. Let us try this. Let ABC be a right angle triangle with hypotenuse BC of length 20 centimeters. P is perpendicular to BC, then the maximum possible length of AP in centimeters is. Alright. If this is going to be my right angle triangle with BC as 20 and I want this perpendicular to have maximum possible length. Now guys, maximum possible length will be generated when these sides are equal. You don't have to find these sides. If these sides are equal, the perpendicular becomes the median. For an isosceles triangle, perpendicular becomes the median and median is half of the hypotenuse. So in an isosceles triangle with two sides equal, if you drop a perpendicular, it becomes the median as well. So this line AP has become the median, and median of a right angle triangle on the hypotenuse is half of the length. This median property is not necessarily true for isosceles. Observe, for any right angle triangle, if I have the sides as 3, 5 and 4, if you drop a median, it will be 2.5 in length. Let us carry on. A man makes complete use of 405 cubic centimeter of iron, 783 cubic centimeter of aluminium, 351 cubic centimeter of copper to make a number of solid right circular cylinders of each type of the metal. These cylinders have same volume and each one has the radius 3 centimeters. The total number of cylinders need to be kept at minimum. The total surface area of all these cylinders in square centimeters is. Now I see a couple of complexities here. There are three different metals. I'm going to form cylinders with equal volume. Radius is 3 for all. That tells me their height is also going to be same. And I want them to be as large as possible so I can minimize the number of cylinders. So here I get an idea. If the height is same and radius is 3, they will have equal volumes. So the total number of cylinders will be proportional to the total volume of these metals. So if I assume the number of cylinders to be N1, N2 and N3, they will be in the proportion of 405 ratio 783 ratio 351. I see digit sum of first and last being 9 and digit sum of central one being 18. So these are multiples of 9. 9 into 45, 9 into 87 and 9 into 39. I can see further multiple of 3, that is 15 ratio 29 ratio 13. Now, number of cylinders of each type cannot go below this. Type 1, type 2, type 3, these are the number of cylinders. One more thing, a volume is given by pi r square h. See, I know individual the number is 15. I can find height from this. That is not the question about. See, I'm assuming the number to be simply n. Leave it there, leave it there. N1, call it N1, 15, is equal to 405. This gives me N1 into pi into h as 45. What is the benefit of this if you ask? In the similar manner, I can find N2 into pi into h as 87 and N3 into pi into h as 39. The benefit of this is I'm trying to find total surface area of all of these combined. What I will need is, because surface area of each one will be equal, I'll need N1 plus N2 plus N3 into pi r h. Now notice here, other than r part, I have already collected this part. So r is 3 multiplied by 45 plus 39 plus 87 is the lateral surface area of the cylinder. This curved surface area I am able to find out for all cylinders. Now, what will be the upper and the lower part, circular part? It will be N1 plus N2 plus N3 into 2r square into pi. Why? The upper and lower parts are circles, 2 pi r square, and this many are there. So again I will have 45 plus 39 plus 87 multiplied by 2 r square into pi. Now if you rearrange these values, your answer is ready here. Oh, in this case, N1, N2, N3 individually are these guys. Don't put 45 here. That is these values that include H. So you have to put here values 15, 29 and 13. Those are N1, N2, N3 values. If you solve this, you will have 1026 common 1 plus pi. See, basically this 9 goes inside, makes it triple. So you have 2 into 3, 2 into 3 outside. That's the same result. So with this question, we have reached end of this session. I hope at least few of you managed to stay till the end. This last was a complicated problem. Answer option D seems correct. Now, you will find solution PDF to this. You will find question PDF to this. You will find the answer sheet PDF to this in the description section of the video. Please share this with your friends. Like and subscribe the channel. I'll see you in the next session. See ya. Bye-bye.